Find the following integral. We've got 5x squared minus 27x plus 22 over 2x plus 1 times x minus 3 all squared dx. So what we've got to here is to split this into partial fractions with a repeated linear factor. Splitting into partial fractions, then 5x squared minus 27x plus 22 over 2x plus 1 times x minus 3 squared will become a over 2x plus 1, and then you have to do b over x minus 3 squared and also consider c over x minus 3. Right, then you need to put everything over a common denominator, so putting both sides under the same denominator, 2x plus 1 x minus 3 squared. Then a has been multiplied by x minus 3 squared. B has been multiplied just by 2x plus 1, and C has been multiplied by 2x plus 1 and x minus 3 in order to keep the same denominator. So now we have the same denominator, we just consider the numerator. So consider 5x squared minus 27x 22 is equivalent to A times x minus 3, B times 2x plus 1, and C times 2x plus 1 x minus 3. So we're going to consider this, making this 0, so it'll be x is equal to minus a half. Now, if you want to work this out quickly on your calculator, put in minus a half using the fraction button, and then press equals, and then do 5 times answer squared, minus 27 times answer plus 22. If you do that, you're going to get 147 over 4. And then here, if you put in minus a half minus 3 all squared, you're going to get 49 over 4. Well, the 4's will cancel out, and then 47 divided by 49 will give that a is equal to 3. Right, the next thing to do is to put x is equal to 3, which will make that 1 and that 1 0. So put 3 into here, you're going to get minus 14. Put 3 into here, you're going to get 7. That gives you b is equal to minus 2. Well, you can't put minus a half or 3 in here because both times these will be equal to 0. So what you have to do is equate coefficients. So just equating coefficients of the x squared term only, 5 will have to be equivalent to 1a, and nothing from here, there's no x squared term here, but you're going to have a 2x squared here, plus 2c. Well, we already know that a is equal to 3, so we've got 5 is equal to 3 plus 2c. 2c will be equal to 2, and c is equal to 1. Now writing out this with a, b and c in, you're going to get 3 over 2x plus 1 minus 2 over x minus 3 all squared plus 1 over x minus 3. So integrating this side is the same as integrating all these separately. Right, this is going to be an ln type, so let's just try differentiating ln of 2x plus 1. If we do that, we're going to get 2 over 2x plus 1, and we wanted 3 over it, so we're going to have to multiply by 3 over 2 in order to just end up with the 3 on the top, and the 2 cancel out of that. Right, next one, you've got to think this is minus 2x to the minus 3 to the minus 2, so if you add 1 to the power, it's going to be x to the minus 1, and when you differentiate that, that will become a plus 2 over x minus 3. Now, if you're not sure, just differentiate this back. So if you differentiate 2 times x minus 3 to the minus 1, if you bring down the minus 1, you're going to get minus 2x to the minus 3 minus 2, and then you have to differentiate the bracket, which is 1 in this case. Don't always assume that it's 1. So that takes me back to minus 2 over x minus 3 squared, which is what that is. So that is definitely the integral of that. This is just a simple logarithm one, so plus ln of x minus 3 plus c. Now applying some rules of logarithms. So r log a of x is log a of x to the r, and log a of xy is equal to log a of x plus log a of y will give a answer of ln of 2x plus 1 to the 3 over 2, applying that rule here, plus ln that, so just multiplied by x minus 3, and then plus 2 over x minus 3 and then a plus c. Okay, so this has been the video to show how to do an integral by splitting into partial fractions with a repeated linear factor and then integrate the fraction. I hope you've understood, and I thank you very much for watching.